Alright, so in this video we're going to look at finding the antiderivative using the power rule. We're going to look at some simple functions to integrate. So if we have the integral of x raised to the n, so all of these we're going to be able to get in the form of x raised to a power. Okay, so if we integrate x to the n dx, this means with respect to x, then all we do is we add 1 to the exponent. That's where this n plus 1 comes from. And then we multiply by the reciprocal of this exponent here. And that's where the 1 over n plus 1 comes in. And then it's plus this constant term c. C is just a number, okay? And n cannot equal -1. So this exponent here can't be -1 in order to use this power rule. Alright, so let's take a look at some examples. So here we have, we're going to integrate 3x dx. So we're integrating this 3x with respect to x. So we know here that the exponent is 1. Okay, so we add 1 to the exponent. So we're going to get x to the 1 plus 1, and we have the 3 in front. Okay, and so 1 plus 1 is 2. So this exponent here will be 2. Okay, so the 1 plus 1 is 2, and then I multiply by the reciprocal of this exponent. So the reciprocal of 2 is 1/2. So that's times 1/2, and then plus our constant term c. So this is going to give us 3 over 2 x squared plus c. And this would be our solution. Let's take a look at another one. Alright, we're going to integrate 1 over x cubed dx. Now, we can't use the power rule on this because the x cubed is down here in the denominator. Okay, so what we have to do is we have to move this term here up into the numerator. So we have to rewrite it. So when we rewrite this, we move the x cubed up. So when we move it up, it changes the sign of the exponent. Remember your exponent rules. Okay, and dx. So I've got x to the -3 dx. Alright, so let's see what we get. I'm going to add 1 to the numerator. Add 1 to the exponent. So that's going to give me x, and -2 plus 1 is -2. And then I multiply by the reciprocal of the new exponent. So that's times -1/2 plus c. And so I'm going to get -1 over 2x squared plus c. So all I did is I made my exponent positive by moving it into the denominator, and that changes the sign of the exponent. So here's my solution. Alright, let's take a look at another one. So I'm going to integrate the square root of x dx. Alright, so remember, we have to have it as x raised to a power. So is there a way that I can rewrite the square root of x? Well, I can rewrite it as x raised to the 1/2. Remember the square root, that's 1/2 power dx. So now I have it as x to the n. So what do I get? Well, I'm going to add 1 to the exponent. So that gives me x to the 3/2. And then I'll multiply by the reciprocal of the new exponent. So the reciprocal of 3/2 is 2/3. So that's times 2/3 plus c. And so this is going to give me 2/3 x to the 3/2 plus c. And this, I mean, you could rewrite it, put it back in radical form, but I think it would be fine just to leave it like this. Okay. Let's take a look at another one. Alright, so here I have several terms. I've got 3x to the 4th minus 5x squared plus x, and I'm integrating this with respect to x. So all we do here is we just integrate each term individually. So this is going to give me, okay, so let's just look at the first term. I'm going to add 1 to that exponent. So there's my 3. And so I've got x and 4 plus 1, that's going to give me 5. And then I multiply by the reciprocal of this exponent. So that's times 1/5. That's a times there. Alright, minus. And then I'm going to add 1 to this exponent. And there's my 5. And so x to the 2 plus 1, that's x cubed. And then I multiply by the reciprocal of this exponent. So that's times 1/3. And then we know that this exponent here on this x is understood to be a 1. So I'm going to add 1 to it. So that's going to be plus, and then x to the 1 plus 1, that's going to be x squared. And then I multiply by the reciprocal of this exponent, so that's times 1/2, and then plus c. And so this is going to give me 3/5 x to the 5th minus 5/3 x cubed plus 1/2 x squared plus c. And this would be my answer. Alright, so let's take a look at one more. Alright, so how about this one? Alright, so first thing that I'm going to do, I'm going to have to do a couple of things to this before I can integrate it. So first thing I'm going to do is I've got x plus 1 over, and I'm going to rewrite the square root of x as x to the 1/2. Okay. Now, remember, we have to get everything looking like x raised to a power. See, I've got to get everything to look like this. Okay. All right. So what we're going to do here is we're going to rewrite it as x over x to the 1/2 plus 1 over x to the 1/2 dx. Okay, so all I did is I split the fraction up. And so this is going to give me, okay, alright, so remember when you have like bases, you subtract the exponents. So this is going to be x to the 1 minus 1/2 plus, and then if I take this term and just move it up into the numerator, that's going to change the sign of the exponent. So that's going to be x to the negative 1/2. And so now I've got x to the 1/2, 1 minus 1/2, plus this x to the negative 1/2 dx. Okay, now I'm ready to integrate because I've got everything in that form, x raised to a power plus x raised to a power. Alright, so now I'm going to add 1. Remember, we'll do each term. And so this is going to be x to the 1/2 plus 1, which is 3/2. And then I'll multiply by the reciprocal of the new exponent. So that's times 2/3. Okay, plus, and then I'm going to add 1 to this exponent. So negative 1/2 plus 1 is 1/2. And then I multiply by the reciprocal of the new exponent. So that's times 2. And then plus my constant term, c. And so this is what we get. 2/3 x to the 3/2 plus 2x to the 1/2 plus c. And this would be my solution. So you can see this problem really wasn't that difficult. There was just a lot of things that we had to do. See, we had to do all of this before we could integrate it. Okay? And that may be the case in some of the problems. Alright, so I hope this video helped. Hope you'll check out my other videos. Thanks.